Welcome everyone to our monthly Intel and AMD CPU vulnerability debriefing here on our channel. Live out, breaking news out today. Two Intel and AMD CPU vulnerabilities, so security vulnerabilities and attacks. One of which is, and also 2023, actually the last year already, vulnerabilities need fancy names, like Downfall and ZENBLEED and stuff, in INCEPTION. Some people hate it. I wrote, let's start with this controversy. Some people really hate it. I personally actually think it's fine because it not only it is better to memorize. Who remembers what Intel Spectre and Meltdown were they? CVE 2019, 11, whatever. It's like, even I don't know, right? So I kind of can understand why some security people hate it, but I personally find it really helpful, not only for us technicians to remember so much more verbose, and also for the general public. Remember when this SSL vulnerability, actually I forgot what that name was, so much to, I don't even know the number and the name, whatever the SSL bleed, whatever. Anyway, so plenty of more attacks, not only Intel but also AMD. And also, let's first discuss it. So downfall attacks, critical weakness in billions, the usual summary, billions of Intel CPUs. CVE, there we have it, 2022-1498-2. And this is, where's even the freaking, this cannot be the summary. It is based on actually, why did I not open the... That's what this was, so, or do I need to click on tech? Where is the paper? Do we need to click on the paper? Exploiting speculative data gathering. I thought there was somewhere another summary, but whatever. Based on AVX instructions, the gathering. So we don't really need to discuss all the details because it is extremely dry. If you want to go into the details, read them here. We better summarize that. That is more. I mean, the concept is the same, right? I discussed it in depth some 3 years ago with the first Spectre Meltdown. When basically 3 years ago it was breaking news. So this live stream today is more of a summary and some honest reflection about the state of the CPUs we are using. And when this was new, and we discussed it here in depth 3 or 4 years ago with Spectre and Meltdown version 1 and then version 2. It is always the same microarchitectural, kind of the same, similar pattern. Training, branch prediction, and gathering samples and data, and so on. We have similar stuff at AMD, and there in the meantime more. If I would find my browser cursor here, sometimes the cursor disappears. AMD interception, how a simple XOR can cause microarchitectural stack overflow. What they observed were phantom speculation and training and transient execution. They can manipulate further mispredictions through previous misprediction that they triggered. And as usual here with some fancy demonstration, leaking password hashes. So that is CVE 2023-2056-9. You see how much more verbose a pretty name is. We also, unlike Elon Musk, we also don't call our children 2056 or birthdays actually not too far off, right? But there is where in my opinion the name's actually quite useful. So another novel transient execution attack that leaks arbitrary data on AMD Zen CPUs in the presence of all previously deployed software and hardware mitigations. Again, training, transient execution, TTE, the usual stuff, training, transient execution, exposing microarchitectural mispredictions and speculation, using phantom speculation, so all TTE attack are interesting. Interception combination of TTE and phantom. Mitigations, as usual full mitigations, branch predictor state has to be fully flushed while switching between distrusting contexts. So this is also the same mitigations, right? What the mitigations are always like flush more data, either in pure software or also in the help, or usually the more you do in software, the more performance penalty there is. And that is why the CPU vendors usually add new, even at times exposing new CPU features and flags and controls for adding this for an operating system to use, because otherwise the performance impact is quite hefty. They found on Zen 1 Plus and Zen 2 this comes with a hefty overhead between 93.1 and 216.9% depending on the specific microarchitecture. On Zen 3 and Zen 4 they did not find proper hardware support to flush the entire branch predictor state. AMD, however, released microcode to has released microcode to enable this in the future. Instead of flushing the entire branch predictor state, AMD proposes different mitigation for the Linux kernel by reducing all returns in the kernel to a single one. It becomes possible to ensure a safe but still incorrect branch predictor state each time the return is executed, keeping previous mitigations in mind. This effectively means that AMD opted to have all indirect branches forcibly mispredicted to binning location, preventing inception attacks. Also previously, some weeks ago, I didn't even make a dedicated video. So you see, for me, I'm busy, right? I don't want to clickbait here the most. And I was in the meantime, okay, we got it, everything except 46s are insecure, so we better install those back in there. Maybe overclock them a little bit to 100 megahertz or so. ZENBLEED from Tavis Mandi. Probably from previous, I probably shouted out here some AVX state rollback vulnerability that also was not fully mitigated, and by the way still is not, right? But I come to this in a minute after the summary. So he further found, probably working further on the month or last year or whenever I shouted out state rollback, finding zeroing registers, guessing, you guessed it, V0 to upper will 0, the upper bits of the vector registers. The reason for this is because XMM and YMM registers and so on. Details, vector register file. Speculation, hold on, there's another complication. Modern processors use speculation, recurring theme here, right? Many new CPU vulnerabilities based on speculation, microarchitectural flaws therein. What should happen is the processor speculatively executed the V0 upper, but discovers that there was a branch misprediction. Yes, there is vulnerability. Turns out that with a precise scheduling, you can cause some processors to recover from a mispredicted V0 upper incorrectly. This technique is CVE 2023-2059-3, also otherwise known as ZENBLEED, and works on all Zen 2 class processors, which includes at least the following products. So Zen 2 class and newer, I believe. So I have issues. So this is basically the summary. The details are to dry for most people. Leave them in the comments below if you want to see more details. I have some other things to add. I'm deeply also, the first thing is, in the beginning, most CPU vulnerabilities were found in Intel CPUs, but this was only because Intel CPUs were speculating more in higher performance. Years ago, before Zen 1, AMD simply was not as high performance, and it's like here, not as much speculating, not as much branches, buffers and stuff. And also, so not only AMD catched up, is now at times leading the high performance, is speculating more. The CPUs are more complex, so there are more vulnerabilities. And also AMD is now more mainstream, often the king of, especially server, epic thread-ripping performance, you guessed it, and with more popularity and king in the performance league comes more security research. So it is no surprise to me that there are now more AMD vulnerabilities. Second of all, I'm really disappointed, and I say this as I never have been an AMD fan or shill, but I liked AMD CPUs and I used them extensively, starting from the Athlon 600, and then also I even used Phenoms. I intentionally 10 years ago brought Phenoms when they were not as performance leading, because otherwise in the office here at Exacode we had too many Intel CPUs, just because we worked with Mac software back in the day. So we had an Intel Xeon in Mac Pros and Intel CPUs in MacBooks, and thus I intentionally purchased the performance wasn't bad, right, of Phantom 2 and so on. So we have racks here of, we still even run them in production because they are fine for what they're doing. Why buy thousands of euro? Then when Zen 1 came, I waited for Zen 1 Plus, I believe, and also then continued further purchasing them, of course, also because the performance was amazing. But I was never a blind fan. I was just realistic, and I used those CPUs just here for but also we used Intel CPUs, right? That being said, I'm really disappointed how AMD handles these vulnerabilities, because similar, I was shocked with the month ago when, I just need to remember the name, Tavis Omandi disclosed the initial, not as widely circulated. I probably was one of the very few YouTubers and news outlets to shout this out, because I saw this scrolling by the message on security related mailing list and stuff, and I tested this here, and this is probably the predecessor to the ZENBLEED, and AMD did never patch that for consumer SKUs, right? And this is also incorrectly written here. The thing is, you need to share, like, subscribe, pattern stuff. Basically, there's so many things to take care of that nobody properly takes care of. For example, even the summary here is incorrect as far as I know, because they write here that this is patched, or where was the list solution? Here's microcode, recommend a microcode update. Also, yeah, just disable some speculative execution chicken bit. Here's like, yeah, if you disable speculative executions, then that goes away with some performance cost. That being said, they write here AMD released a microcode update for affected CPUs. So my understanding is this is incorrect. AMD has released a microcode update for affected server grade CPUs, because I was shocked myself. Maybe I need to remember names, man. Too many names. Tavis. He probably didn't investigate this further, but I investigated it the last time, and I was shocked. I investigated this for the initial AMD YMM AVX register state. And I was shocked to find that these microcode files in Linux firmware here do not match to desktop SKUs. I even wasted time. I wasted another hour of my life a month ago, or 2 or 3 months ago, or whenever that was, because I even patched the Linux kernel, because I used that and I tested this, because the Steam Deck is affected, the Ryzen 3000, our 3950X, and I would need to check, maybe the 5950X is also affected. And I applied this microcode update, and I debugged for an hour on this stuff, right? Recurring theme here, I do stuff and it doesn't work. And then maybe I even spent more than 1 hour. I remember I instrumented the Linux kernel code and added their recurring theme here, right? 2023, we still debug with printf. And I even, because I was wondering, like, why the freaking heck is the security vulnerability still there, right? And I instrumented the kernel code with printfs and stuff, what is applied, what is matching, and figured just to come away, yeah, this stuff doesn't match, right? So you see this here already, Microsoft patch in microcode FAM17 hex and stuff. They add here model 31, model A0, so stepping 0. So I just switched, wait a second, this is the other, do I have it on? Anyway, so last time it didn't match, and I'm pretty sure this still doesn't match, because as far as I remember, this added matches here do not include, they also just moved this up. So yeah, actually, so they moved this up and they added 17A0 here. I'm 99% confident this is not adding consumer SKUs. So they only patch Threadripper here, right? Maybe Epic? I'm not sure about Epic. I think this mostly the last time it matched Threadripper. You can decode it. Also, this is in this field, right? So this is only, the textual stuff here is only information for the educated reader. The other stuff is here in this binary files, right? Is this just the signature, right? Also, these patches are very small, right? So I'm also shocked. The AMD, so the reason also the Intel, so I have as much as I have not been an Intel fan or still have not been an Intel fan, I have give credit where credit is due, and actually a reasonable menu, right? When something sucks, I say it sucks. This AMD microcode sucks. It does not patch most SKUs most people run. This AMD is signaling here some false security that is not there because people think it's fixed and without further checking. And credit where credit is due, Intel patches it actually for many more CPUs, right? Also Intel is not patching 7-year-old, right? For other security vulnerabilities, I check, they are not patching oldest Haswell and whatnot SKUs, right? So you only get some 5 or whatever years, times whatever. Maybe people find it reasonable, although also like if you have old stuff at Intel, it is most likely not fully patched, right? We could check this actually. This is AMD ZENBLEED. Actually, on the website also, it's a typo there. Of course, I had a typo. On the website, actually, the last time I checked, AMD is communicating that. So yeah, this was 25th July. It's actually not that long. Where is the link to the? I'm only after the AMD. I want the AMD website. Published. Since published, is it that here? Cross Process Information Leak. And on some website they published. Okay, they also write your desktop. So yeah, you get some mitigation maybe with some AGESA. But the last time I checked this, it was not in there, right? That was last month. So I've not rechecked that. Also the names, right? Combo, AM version 2, PI is like... Also, wait a second. Ah, right. I just realized it here, target December. So it's exactly how this confused me. They tricked me again, right? Although I knew I reviewed this some days ago and it said target. So it's not patched yet, and that is my biggest criticism of this, that they target that, right? And whether they really release it. I mean, first of all, I find December long. They have the microcode for Threadripper. The last time they updated this for the YMM register state rollback bug, they have only published Threadripper and Epic and Linux firmware, and they still don't do it, right? And the microcode is most likely entirely the same, right? The CPU scores are the same. Maybe some surrounding bits are different, some fusing, some processor name, some who knows what, some CPU ID, but most likely the main payload is most likely identical, right? It's not like they have other CPU cores for Ryzen and Threadripper. So they target this for, here is also some other high-end desktop stuff, target October 2023. Okay, that's not that long, but other stuff is patched already, I believe. Like, why do they not? My point is, AMD needs to make a better job. As I said already a month ago when I shouted this out for the general AVX register rollback, where they didn't fully patch it, they still don't fully patch it. And in my opinion, for like, you could steal your online banking stuff, right? Or whatnot, or websites hack into your desktop and encrypt all your ransomware files. And December is way too long. Also, as per usual, the chance is, it is in the news, they promise they fix something and they never fix something, right? We don't know, it could be. In my opinion, that is not how it should be handled. AMD is not an underdog anymore. They're a multi-billion-dollar company with recently good profit. And profit or not, this is some multi-billion-dollar business also for consumers and also enterprise-run servers on Ryzen. Lots of normal end-user desktop and normal medium-sized companies. Last but not least, this also could be better, right? So how many security, like major security vulnerabilities did we have recently, right? So as I mentioned in the beginning, names, right? Who remembers? Even I didn't remember that anymore, right? 2017 already. So that's actually a long way coming here. Spectre version 1, bounce check bypass, Spectre version 2, branch target injection, Spectre RSB, Red 2 spec return mispredict 2018. I don't need to read some minor numbers. Then we had meltdown, rogue data cache load, Spectre NG version 3a, Spectre NG version 4 speculation store bypass, foreshadow. Also, like, so much to all the haters who hate those names, like foreshadow and stuff. It's like, hey, at least you have a proper name. Like, who remembers? It's like, even if you discuss with engineers, have we fixed 2018, like CV 2018 3615 already? It's like 3016 15. Which one was it? Foreshadow, of course. L1 terminal fault, Spectre NG lazy FP state, restore Spectre NG version 1.1. Absolutely crazy how many variants, right? Bounce check bypass store, foreshadow OS, L1 terminal fault, foreshadow VMM, L1 terminal fault, RIDL zombie load, microarchitectural fill buffer, data sampling. Also here you see affected, not affected, microcode OS. This is for Intel, Ice Lake and Coffee Lake and stuff. And also where previously AMD was not as often affected, but also not as high performance. Then we had Riddle microarchitectural load port data sampling, uncacheable memory, fallout, microarchitectural store buffer data sampling, Spectre swap GS, Riddle zombie load version 2, so microcode and OS, right? Riddle vector register sampling, load value injection, crosstalk, branch history injection, red bleed as region is 2022, cross-red return address predictions, ZENBLEED, and collide and power. Did I shout this out? And now downfall, INCEPTION, and additionally, previously AMD quietly lists 31 new CPU vulnerabilities, issues patch guidance, like maybe we patch this in December if you're lucky and we don't forget about this. But don't. Also, the problem with that is targeting biases, right? Where do you even have this of all the... here. I really want to do this running my servers, right? I don't want to have even longer outage. I don't want to flash the BIOS. This should be published to use in Linux firmware, also to use with BSDs and so on. Similar to how many Intel vulnerabilities have been in the meantime, right? Last but not least, I want to close. So that is the state, new vulnerabilities. As people say here in some introduction here, they somewhere write, most likely you are affected. Targets critical, was it this one? Critical weakness found in billions of modern processors used in personal and cloud computers, the new mainframes. Vulnerability identified here enables users to access and steal data that users who share the same computer, for instance, a malicious app in the App Store or your browser plugin, or website then in JavaScript. Steal sensitive information like passwords, encryption keys, private data such as banking details, personal email, messages. Similarly, in cloud computing environments, malicious customer could exploit downfall vulnerability to steal data and credentials from other customers who share the same computer. Think all your storage, your compute power, even from companies you use, right? Web services from X, previously known as Twitter, Facebook, or Google. And last but not least, I wanted to say, we really need to, or the big companies, I wanted to say two more things, only 27 minutes. My further thoughts to this issue is, these are only the main vulnerabilities we know at x86, Intel and AMD, right? Previously, VIA was never good. They were purchased by Intel anyway. But now with all the ARM CPUs, I expect with ARM and now upcoming RISC-V, there are many, many more such vulnerabilities that are in there that researchers simply don't cover. I expect the same amount of vulnerabilities in there, maybe even more, although at entry-level CPUs, on entry-level CPUs, without speculation and stuff, of course, there are less bugs to be made, right? Because no speculation, no transient execution attacks. However, the more high performance, think Apple, highest performance Apple silicon, and other high-performance ARM, all the Snapdragon and all the other variants, Ampere and so on. I expect them to have similar bugs, just they are not discovered because researchers target the high profit and low-hanging fruit that are the x86 CPUs. I expect Apple and ARM CPU, other ARM CPUs, and also upcoming RISC-V. And that is also why it takes so long. When people ask, why does it take so long for RISC-V? We previously made a video last year or so already with new High-5 cores coming with wider instruction and out-of-order execution. And it takes a lot long to verify them, right? To do formal verification, because you don't want to release CPU cores, especially to your licensees, and have this in millions of devices, think next generation storage and stuff, and have then vulnerabilities in your precious new RISC-V core that soon come to all your IoT, edge and cloud and carrier grade and AI. And last but not least, I would suggest we really need to think the whole computer science. I probably said this before, to design CPUs differently, right? Because in my opinion, these are too many bugs. If I would be a architecture lead at Intel, for me, this would be too many bugs, right? Although I have to say this Spectre and Meltdown transient execution attacks were novel. Novel approach. Nobody really, although I would say they were warned. There was already lots of research and lots of glitches found previously. In 2017 it was a novel approach, but we are here 2023, soon probably 6 years later, and we still get new such vulnerabilities, right? And with wider execution, with more speculation, with more performance, people demand performance. The only substitute for performance is more performance. So they want their 20% architectural IPC uplift for each generation of CPUs. And with such demand, with such high pressure of Intel AMD to deliver new CPUs next generation with 20+% or preferably 40% more performance, 20 in IPC uplift and 20 in bigger buffers and caches and memory channels. And maybe it is better to do a more RISC approach. Of course, the x86 CPUs are RISC internally. But what I mean with that is not have as complex instructions. All those extremely complex AVX, just look in there, what kind of like the downfall, right? Just here, or I mean, they all are here also with INCEPTION, and also where did I even, here, I clicked here, ZENBLEED in AVX state, right? And sure, we want as AMD, we want vector extensions, but keep them more reduced instruction set. And even if it costs you some 5 performance here and 5 performance there, we are in an increasingly connected world, and with China and North Korea and the United States and everyone else breaking into each other's systems regularly, plus all the other regular criminals, with online banking and everything, everyone's life being digital these days and being in the cloud, things need to be more secure, right? And we should have higher standards. And higher standards, I would say, if I would be such a CPU designer, sure, if I would work at Intel, I would have a problem because this x86 stuff is just so complex, so I would preferably work at some RISC-V foundry. But then make stuff more reduced, less complex, and maybe even compensate that for higher clocks, although even higher clocks are certainly different and difficult in energy, but higher clocks we are getting there. Or simply more cores, right? Instead of overly complex single instruction multiple data instructions that take enormous space, so much that Intel didn't ship it anymore in desktop SKUs, just double the cores, right? Good. Sure, programming that is more difficult, but it is not impossible, right? We see this in GPU, just how modern AAA games look, and the embarrassingly parallel compute power of GPUs. And sure, GPUs and CPUs are a different thing, but I nonetheless would say we can't or we should not I would want to envision a world that is more secure and not vary every quarter or at times every month, or now in this case AMD ZENBLEED was just last month, right? It's just some week ago or two, where on a monthly basis we have CPU vulnerabilities. And as a computer scientist, for me this is simply not acceptable, right? And it should not be acceptable, similar to how it's not acceptable that AMD is not publishing patches in a timely manner and communicating precisely, especially with open source operating systems, which patches even apply and that consumer SKUs are not patched there, that CPU should be more secure. And in my opinion, we can't, as you see here, sure, a decade ago I could not envision this kind of transient attacks, but I neither worked in CPU design nor in such kind of security research. It is absolutely mind-blowing, this kind of transient execution attacks, but in the meantime they are known for soon a decade. And going forward, I don't know how Intel and AMD and all the other ARM vendors, ARM and all their licensees, or RISC-V, how they want to design CPUs that do not have such transient and speculative execution attacks. So my only solution, I mean, sure, you could always say like, yeah, like firewalls, like make transient execution kind of firewall microarchitectural changes, which is of course what Intel and AMD are doing in terms of adding kind of transient execution state, more secure and not leaking it by tweaking it. But that is of course only going so far, right? And as we see, it takes years. At times Intel and AMD are not fixing all the CPUs, and it takes weeks or months until patches might become available. And then at the end of the day, many people don't even run them because they're not even aware of that, and so on. Or they disable it intentionally because they want performance. So the only conclusion I can come away with that is CPUs need to be further reduced. Of course, x86, we can discuss this in further details. Many people of course know them already, that they are not implementing x86 internally anymore, but some internal microarchitecture that they translate that to. And sure, RISC-V is some way to do that, but most people do not want to give up their x86 Windows software anyway. But even on x86 land, sure, you could say get away with all the extremely complex AVX instructions, and in some way Intel did, just to reintroduce them again as AVX 10 previous video, which is just AVX 512 under a different name and another subset with 1256 byte instructions. So yeah, leave in the comments below. But in my opinion, this amount of bugs is unacceptable, and also it is degrading performance, right? Even with all the other attacks, we already lost 5% there, 10% there, even with mitigations in place, right? All those mitigations don't come for free. And in a way, the CPUs are also then not performing as advertised anymore, right? If Intel advertised you get this performance, and then a year later you already lost 10% performance, and another year later you lost another 10% performance. So you could argue you got 2 years worth of some performance, and now you don't get, like here, you don't get security updates, right? 2023, 2024, brave new time, brave new future. We are at this, we are in a timeline where CPUs are so embarrassingly complex that you don't get software updates, you don't get security updates anymore for them, right? Or in terms even today, it's like AMD, it's like, yeah, YOLO, whatever, you probably get them in December, hopefully, if we find time and resources to do it. Until then, it's like, yeah, YOLO, your mileage may vary. It's like goodbye and good luck. By the way, we have the next 10 architecture coming, right? You probably want to buy that anyway. So yeah, that's basically the summary and some thoughts about that. I hope you found this useful. Let's take a quick look to the comments. Otherwise, it's already 37 minutes to summarize the thoughts and state. Comment there, how many vulnerabilities have we probably built in over the last 40 years? Yeah, and even 386 wasn't bug-free, right? Maybe even 8086 wasn't bug-free. 386 had some pop-A or whatever, pop-A, pop-F, whatever that was. We had Pentium had initial floating point table typos, and then after that only more bugs became right. But again, I have to give Intel and AMD credit where credit is due of at least publishing most in erratas. VIA nearly never has done that, or leave in the comments below. I think I have never seen an errata, or at least not really. And also all the ARM vendors, right? Or don't expect Apple to publish erratas of their bugs, and all the other ARM vendors, right? Although at times you found erratas for some MIPS and ARM CPUs of this and that kind of state, but in broadly speaking, the amount of published erratas in non-x86 CPUs is certainly sure. They are less complex and certainly they have less bugs, but they do have bugs. I mean, recently I found in the just shipping Linksys access point, right? Even there in the GPL compliant published sources, some CPU idling is not activated, right? So probably all the millions, billions access point consume more power just because idle state is buggy and doesn't always wake up and interrupt then. It's like, who knows about that? I mean, only I knew that because I scrolled in the sources a bit and so on to potentially support this, and D2 Linux obviously. Travexa writes more cores won't necessarily help with all types of speculation. Shared resources and speculation have some of those risks. More simpler cores would be a security win for sure, but isn't without. Sure, it has trade-offs, but certainly Intel and AMD are not getting. I mean, in general, it is also, I would expect a CPU to be relatively bug-free, right? When I grew up, I always thought like CPUs are bug-free. And it's like, now we have so many bugs, we can't even remember the names or numbers anymore, right? You would ask how much performance loss with mitigations will Ryzen turn into Ryzen 3 year. And that is a thing, right? I'm not sure if they... It depends on the final microcode provided. Right now I can't benchmark it because AMD only patched. Do we still have it here? AMD only patched Threadripper or so. I would need to check. So Trainium family 17. It's like basically I need to check my own hardware listings here of hardware that would be board. I have a. Let's check the AM4. That is a. Did I not list the workstation board here? Did I forget something? Did I not list the workstation board? Ryzen's 2700, so that is family. This also, they list 23. I need to convert the family to whatever. What is 17 hex? It's 23. The numbers, by the way, also the last time I checked, the numbers were also a little bit nah. So that is 17, and then we have here Model 8. Where even was I? All right, I was here. Model 8. So it's not that model. Here's some 17, 8 stepping 2. It looks actually that there's supposed to be 7, 8 stepping 2. Interesting. Does it mean that in the meantime patch there's something for 17? No, so they did not patch this, for example. So they didn't touch it. But I'm surprised it is in there at all, because the last time I checked, I didn't have. What did they? Okay, they updated something. Wait, is it even the latest one? Because this is not, or is this update from? Okay, so this update is just some weeks old already. The question is, this is just update. Why are these 2 commits? Oops. Yeah, anyway, and then you need to decode whether your firmware is in there or not, and that is what I meant with Intel is doing a better job of. I mean, the Intel, you already see this, the Intel firmware is much more. I clicked here somewhere stupid. Right. I clicked there. So you could go through this README. Is it the latest revision? what did they patch here, by the way? Update microcode 17. 30. Okay, this is just for one. Yeah, the problem is also, but this is also the same thing, right? Where some haters hate where both names. I mean, there are so many CPUs now, even I don't remember which model and stepping is which of those, right? And not to forget the Steam Deck is, by the way, I think the problem is with the custom APU, I believe it is some model 45 or something very high crazy. And chances might that for custom APUs you might never get microcode, to be honest. Just to... Yeah, 144, whatever that is in hex, it's like, yeah, good luck finding microcode patches for 2344. Stepping 2, it's like, yeah, probably ain't patch there. Unless, I mean, Valve might not want to patch it because it costs performance and the games run slower, so don't expect your Steam Deck to be particularly secure then. Anyway, let's go back here, let's take a look at the last comment and then call it a day. Guess 3 weeks old. Yeah, then some benchmarks. Always disabled mitigations on Haswell and Skylake to get playable frames. The XVK games, otherwise it's a slideshow. Yeah, I mean, truth be told, even I, until like on the non-Ryzen 5000, on the older Ryzen, I also disable mitigations because we don't really have external access and stuff. So for example, for build servers, I also run with mitigations off or whatever that is to get some 12 or 20% performance back, right? It's like, that's the reality of CPU vulnerabilities. That's it for this video. I hope you enjoyed to learn something. As always, leave me your thoughts and comments below. Have a good day and night. Don't forget to apply your microcode updates. And I hope to see you soon for all the next videos and CPU vulnerabilities to come.